So in the distinguished point SN1, SN2 and SN1. So what about the SN2 reaction? It is a second order reaction. So SN1 reaction, it is the first order reaction. So in the SN2 reaction, there is the only one step mechanism, but in case of SN1 reaction, there are the two step of mechanism here. So that point is important here. Next one, it is a bimolecular reaction. Means there are the two molecules are involved in the reaction. So that's why it is a bimolecular reaction. Next, the distinguished point in the another side. So in case of SN1 reaction, it is unimolecular reaction. It is a unimolecular reaction because there is only one molecules are involved in the reaction. So that's why it is a unimolecular reaction. Okay. So what about the next point here? So in case of SN2 reaction, so you know that the reaction is one step and there is only one transition state formed in the reaction. But before that, there is a breaking of CBr bond and formation of COH bond. So both the process takes place simultaneously in case of SN2 reaction. But in case of SN1 reaction, there is no simultaneous breaking of CBr bond and formation of COH bond. So in the SN1 reaction, first there is a breaking of CBr bond in the product side, and then first there is a breaking of the CBr bond, and then there is a formation of COH bond in the product side. Okay, so that thing is important here. So again consider here, it is the one step reaction. It is a one step and formation of one transition state. One transition state. इथे किती transition state तयार होता? One. Okay. But in the other hand, so what about the SN1 reaction? It is a two step and formation of two transition state. किती transition state तयार होता? There are the two transition state. So that point is important here. Again the next point here. So there is a simultaneous breaking and making of bond. So that point is important here. So here simultaneous breaking of CBr bond and making of COH bond. Okay. So simultaneous breaking of CBr bond and making of COH bond. But this thing is not happening in this case. So here breaking of CBr bond first, and then making or formation of formation of COH bond in product. So it is not the simultaneous process. That thing is important here. So here simultaneous breaking of CBr bond and breaking of COH bond. But in this case, breaking of CBr bond first and then formation of COH bond in the product. Okay. So that thing is important here. Next, that is the only. This is important here. Only primary alkyl halides shows this reaction. Only primary alkyl halide shows this reaction. But in this case, so what is the next point here? That is the sixth one. So in this case, only tertiary alkyl halides shows this reaction. Okay. So that thing I will explain later on. But in this case, only tertiary alkyl halide shows this type of reaction. So that is nothing but the SN1. Okay. So these are the some points that distinguish between SN2 and SN1. So what about the next point here? So you know that there are the two types of solvent, polar solvent and non-polar solvent. And generally, SN1 reaction is favorable in the SN1 reaction is favorable in polar solvent. But what about the SN2 reaction? SN2 reaction is favorable in non-polar solvent. SN2 reaction कशामध्ये favorable आहे? Non-polar solvent. The 7 point it is favorable. It is favorable in non-polar solvent. It is favorable in non-polar solvent. Okay, but what about the SN1? So SN1 reaction is favorable in polar solvent. म्हणजे कशात होते? polar solvent मध्ये generally favorable. Okay, so it is a favorable in polar protic or you can say the polar solvent. कशामध्ये favorable in polar solvent मध्ये. Okay, and this is nothing but the distinguish point between the SN1 and SN2 here. But one thing is remember here again that the last point here. So that last point is nothing but that is the important point. In case of SN2 reaction, there is a need of the strong nucleophile. But in case of SN1 reaction, there is no need of the strong nucleophile. Why in the case of SN2 reaction there is a need of strong nucleophile? Because what are the nucleophile is directly attached from the back side to the carbon which is attached to the halogen, that is the Br. So that's why in this case there is a strong nucleophile is needed. So strong nucleophile is required. Strong nucleophile is required in case of SN2 reaction, but in case of SN1 reaction, weak nucleophile is also favorable, or weak nucleophile is also shows the reaction. Weak nucleophile shows or weak or strong, दोन्ही पण चालते. Weak nucleophile is also shows SN1 reaction. Weak nucleophile is also shows or you can say the favorable. So that are the distinguished point between the SN2 and SN1 reaction. So after that distinguished point, we will see some example based on the SN1 and SN2 mechanism. Okay. So today your homework, that is the differentiate between SN2 and SN1 reaction. That one question remember here. So we will go through the next point. So that is nothing but the examples of SN1 and SN2 reaction. So before that, you know that in case of alkyl halides, so primary alkyl halides, tertiary alkyl halides and secondary alkyl halides. So among that primary, secondary, tertiary alkyl halides, which alkyl halide shows SN1 reaction, which alkyl halide shows SN2 reaction. So that thing important here. So that's why I go through directly some examples that are based on SN1 and SN2 reaction. Okay. So before that, you know the order of reactivity of alkyl halides with SN1 and SN2 reaction. Okay. So order of reactivity of alkyl halides. So order of reactivity of alkyl halides with SN2 or SN1. So order of reactivity of alkyl halide with SN2 or SN1 reaction. So you know that there are the different type of alkyl halides. So alkyl iodides reacts faster than alkyl bromides, react faster than alkyl chlorides, react faster than alkyl chlorides. So why this happen here? I have already told you that. So what are the bond between carbon and iodine is the it having the bond strength is less or the bond length is more. So that's why this bond is easily break, and that's why the reactivity of alkyl iodide is more than the alkyl bromide, alkyl chloride and alkyl chloride. Okay. So why this happen here? Because what are the good living group here? So you know that halogens are the good living group, but order of the good living group is like that. So what are the living group here? So living group here, nothing but the order of the living group here. So you know that I minus live faster compared to Br minus, compared to Cl minus, compared to So that is the order of the leaving group. So which group is first leave here? So I minus group is first leave, then Br minus, then Cl minus, and then F minus. So these are nothing but the order of the leaving groups. So according to that, what are the order of reactivity of alkyl halide with SN2 and SN1 is like that. Alkyl halide react faster than alkyl bromide, then alkyl chlorides, and then alkyl chlorides. Okay. So again we will go through the primary, secondary, tertiary alkyl halides. Suppose I take some example here. So this is the primary alkyl halides. Okay. I take the next one here. That is the secondary alkyl halides. So this is the secondary alkyl halides. Okay. And I take the third example here. That is a tertiary alkyl halides. So this is the tertiary alkyl halides. So these are the general formulae of general representation of primary, secondary, tertiary. So why it is called the primary? Because halogen is attached to the primary alkyl halides. So why it is called the secondary? Halogen is attached with the secondary alkyl halides. So why it is called the tertiary? Halogen is attached with the tertiary carbon. So that's why it is called the tertiary alkyl halides. Secondary alkyl halides, primary. But which alkyl halide shows SN1 and which alkyl halide shows the SN2? So no doubt, always primary alkyl halides always shows SN2 mechanism. That thing important here. Primary alkyl halides always shows SN2 mechanism, but tertiary alkyl halides always shows SN1 mechanism. बघा दोघांमध्ये फरक लक्षात घ्या की प्रायमरी अल्किल हलाइड जेव्हा येणार आहे तो ऑलवेज तुमचा SN2 मेकॅनिझम शो करणार आहे. म्हणजे तुमचा जो अटॅक होणार आहे तो कसा होणार आहे? ऑलवेज बॅक साइड होणार आहे. पण जेव्हा टर्शियरी अल्किल हलाइडची केस येते तर बॅक साइड अटॅक येणं पॉसिबल नाहीये किंवा फ्रंट साइड अटॅक पण पॉसिबल नाहीये. त्यामुळे पहिले काय होणार? ब्रेकिंग ऑफ द CBr bond or you can say the CX bond. So at that time the tertiary alkyl halides always shows SN1 mechanism. But what about the secondary alkyl halides? So secondary alkyl halides, it is intermediate or it is in between SN1 and SN2. So secondary alkyl halides maybe show SN2 or maybe show SN1 depend on the reaction condition. What are the substrate attached here? So that is nothing but the secondary alkyl halides maybe show SN2 or maybe show SN1. But obviously, what about the primary alkyl halides? They always show SN2. What about the second tertiary alkyl halides? They always shows the SN1. And one thing remember here, in case of SN2 reaction, strong nucleophile is needed. But in this case, tertiary alkyl halides, so weak electrophile पण चालतो, weak पण चालतो, strong पण चालतो, काही प्रॉब्लेम नाही. Okay, so there is a weak or strong nucleophile. Nucleophile is needed. Okay. तर SN2 मध्ये तुम्हाला स्ट्रॉंग न्यूक्लियोफाइल असला पाहिजे तरच SN2 रिएक्शन जाणार आहे. आता बघा सेकंडरीच्या केस मध्ये काय? जर तुमचा न्यूक्लियोफाइल हा स्ट्रॉंग असेल, if the nucleophile is strong, then the reaction goes through SN2 mechanism. If the nucleophile is weak, जर न्यूक्लियोफाइल जर वीक असेल तर तुमचा रिएक्शन कोणत्या मेकॅनिझम जाणार आहे? SN1. So that thing important here. आता हे सर्व तुम्हाला मी जे सांगितलं हे केव्हा समजेल जेव्हा आपण त्याचे ऍक्च्युअल एक्झाम्पल्स इथे घेऊ, मग तुम्हाला क्लिअरली समजेल. ओके, मग लक्षात घ्या, प्रायमरी अल्किल हलाइड्स ऑलवेज शोज SN2 mechanism, tertiary alkyl halides always shows SN1 mechanism. But what about the secondary alkyl halides? It may be sometimes show SN2, maybe sometimes show SN1 reaction. Okay, so we go through the some examples here. So I take here again examples of primary, secondary, tertiary alkyl halides, and I write the order of reactivity order of reactivity with SN2 or SN1 reaction. Okay, so that is the important here, that things are always asked in the NEET, JEE and CET exam. So that point is important in this from these two reactions. Okay, so let us go through the some examples here. So I will take here the primary, secondary and tertiary alkyl halides and find out its order or reactivity order towards SN1 as well as SN2 reaction. Okay, so I take some examples here. So I take first one, that is A, and you have given the 3 alkyl halides. So like that. Okay, so this is a tertiary one, no doubt. CH3 CH2 CH2 here Br. Okay. The next one CH3 CH. So what is the CH3 here? So here Br. Okay. The next one is like that, CH3 CH2 and here Br. Okay. So these are nothing but the these are nothing but the alkyl halides. Sometimes it is nothing but the tertiary alkyl halides. Okay. So this is nothing but the primary alkyl halides, and this is the secondary alkyl halides, and this is again the primary alkyl halides. Okay. But among that, which alkyl halides shows SN2 reaction faster than the SN1? So that's why there is a need to see the order of SN1 and SN2. So first see the order SN2. SN2 order. आता बघा या चार मधला कोणता alkyl halide हा SN2 reaction fast दाखवेल. So that's why I can go through the again back to the SN2 mechanism. So you know that in the SN2 mechanism, primary alkyl halides always preferred SN2 mechanism. So let us we give the numbering. So this is the A molecule, so this is the B molecule, this is the C molecule, and this is the D molecule. Okay, so let us see ABCD. These are the 4 molecules, and you have to write the order of decreasing order of the SN2 reaction, or you can say the increasing order of the SN2 reaction. तुम्ही काय करताय ते increasing order, म्हणजे आपण लेफ्ट टू राइट जर गेलो तर ऑर्डर काय होणार, डिक्रीज होणार. ठीक आहे. मग त्या केस मध्ये आपल्याला बघायचंय सो ऑर्डर ऑफ SN2 रिएक्शन. आता बघा 4 मॉलिक्यूल तुम्हाला दिले, 4 मॉलिक्यूलचं ऑब्झर्वेशन करा. आता बघा पहिले प्रायमरी alkyl halides SN2 रिएक्शन शो करतो. मग बघा प्रायमरी मध्ये कोण कोणता आहे, B आणि D. पण दोघांमध्ये फरक लक्षात घ्या. This is also primary and this is also primary. But in this case, what are the CH2 is attached with only one CH3. But in this case, what are the CH2 is attached with CH3 and CH3. Sorry, CH2 and CH3. So this is the bulky group and this is the bulky group. But if you compare these two groups, here is methyl and here ethyl. So among that, ethyl is a smaller group compared to ethyl. So that's why from B and D, first of all from B and D shows faster SN2 reaction compared to B. दोघांमध्ये लक्षात आलं काय झालं बघा, D आणि B मध्ये लक्षात घ्या दोघं पण प्रायमरी alkyl halides आहे. आता पण असे प्रायमरी alkyl halides जर आले तर त्यामध्ये काय करायचं बघा, कोणता या दोघांपैकी कोणता फास्ट रिएक्शन दाखवतो, तर त्यासाठी त्या प्रायमरी कार्बनला कोणते ग्रुप अटॅच, बघा इथं कोणता अटॅच आहे, CH3. या केस मध्ये कोणता अटॅच आहे, मिथाइल. बल्कीनेस जेव्हा वाढतो तेव्हा रिएक्शन ही SN2 कडनं SN1 कडे जाते. ठीक आहे, लक्षात घ्या. आता बल्कीनेस कुठं कमी, इथं D मॉलिक्यूल मध्ये कमी, म्हणून D चा SN2 ची ऑर्डर जास्त आहे B पेक्षा. ठीक आहे. आता बघा B चा आणि D चं काम संपलं. आता राहिला प्रश्न C आणि D. आता यामध्ये तुम्ही नो डाऊट इझिली तुम्ही सांगू शकता C कोणत्या टाइपचा alkyl halide आहे, सेकंडरी. सो दॅट्स व्हाय सेकंडरी आल्सो शोज faster reaction than the tertiary. Okay, but tertiary कोणता आहे A. So in this way you can write the order of reactivity with SN2 reaction. Okay, so what about the SN2? SN2 ची ऑर्डर ही झाली, but what about the SN1 reaction? आता SN1 reaction मध्ये काय होणार आहे, जस्ट रिव्हर्स होणार आहे. रिव्हर्स म्हणजे काय, A tertiary तो फास्ट दाखवेल, त्यानंतर B सेकंडरी, त्यानंतर A पेक्षा काय दाखवेल, कमी दाखवेल. त्यानंतर C आणि सॉरी आता बघा C. सो हियर C काय तुमचा सेकंडरी, A काय टर्शियरी. मग टर्शियरी ऑलवेज शोज SN1. त्यानंतर कोणता सेकंडरी, त्यानंतर कोणता प्रायमरी. आता दोन प्रायमरी बघा, B आणि D तुमच्याकडे प्रायमरी. मग यातला बल्कीनेस कोणाकडे जास्त आहे, B मध्ये, म्हणून तुमचा ऑर्डर काय येणार आहे B, आणि लास्टला काय येणार आहे D. म्हणजे बघा एक्झॅक्टली अपोजिट टू द SN2. So that is the order of reactivity with SN1 reaction. Okay, and this is the order of reactivity with the SN2. मग आता SN2 आणि SN1 मधला तुम्हाला फरक समजला असेल. पण काही एक्झाम्पल असे पण असतात बघा. Suppose I take this is a example here. So all are they are in the primary alkyl halides. Okay. So all they are primary alkyl halides. So CH3, CH2. So here I take here C. Okay. And last one is here that is a CH3, CH2, 4. Okay. These are the 4 molecules. Next example. आता हे 4 मॉलिक्यूल बघा. सो ऑल दे आर प्रायमरी अल्किल हॅलाइड्स. सर्व कोणते प्रायमरी अल्किल हॅलाइड्स. Why it is primary? Because what are the halogen, they are attached to the primary carbon. But if you decide the order of reactivity towards SN2 or reactivity order with the SN2 reaction, कशी काढणार बघा. त्यासाठी परत कन्सेप्ट लागेल तुम्हाला की लिव्हिंग ग्रुप कोणता चांगला येतो. which group is live first here. So those group having more size. कोणत्या ग्रुपची साईज मोठी आहे. आयोडीन. त्यानंतर कोणाची साईज आहे. ब्रोमीन. त्यानंतर कोणाची क्लोरीन. त्यानंतर फ्लोरीन. मग या केस मध्ये आपण ऑर्डर कशी लिहू शकतो बघा. टुवर्ड्स SN2 रिएक्शन. सो which group is the good living group here. Iodine. So that's why CH3 CH2 and iodine, that is the ethyl iodide, shows faster SN2 reaction compared to ethyl bromide, compared to ethyl chloride and compared to ethyl chloride. Okay, आता बघा सगळे जर प्रायमरीचे एक्झाम्पल्स घेतले पण इथं हॅलोजन वेगळा आहे बघा. इथं बी आहे, इथं आयोडीन आहे, इथं क्लोरीन आहे, इथं फ्लोरीन. मग त्या केस मध्ये ऑर्डर बघायची. पहिला लिव्हिंग ग्रुप कोणता आहे. I-, दुसरा कोणता आहे. Br-, तिसरा कोणता आहे. Cl-, चौथा कोणता आहे. F-. मग त्यानुसार आपण याला काय करू शकतो. अरेंज करू शकतो. ओके. सो दिस इज नथिंग बट द order of SN2 reaction with all are primary alkyl halides, but there are the different types. One is the ethyl bromide, ethyl iodide, ethyl chloride, ethyl fluoride. So you know the concept very well here. So which group is a good living group here. I-, then Br-, then Cl-, and then F-. So according to that you can write the order of reactivity of primary alkyl halides. Okay, so these all are nothing but the primary alkyl halides. Okay, let's we go through some different example here. So in that example you might be know that sometime the reaction is go through SN1, sometime it go through SN2. Okay, so such type of example here. So I take the example here. So here that is nothing but the CS3. Okay, so let us see the some different example here and then okay, so I will take here that is a aromatic containing alkyl halides. So this is a nothing but the benzene and it is attached with the Br. Okay, so this is the benzene, it is attached with the Br. The next one, so I say it is a A molecule. Next molecule here, so I take here secondary. So this is the secondary. Okay. And here Br. All they containing bromine, but this is the secondary. So this is the B molecule. Next one here. That is the Br, and here CS3. And what is the last? So this is C molecule. And what about the D molecule? So D molecule is like that. Here Br and here CS. So what is the difference between all these four here? That thing is important. If you arrange the all that four molecules according to the SN2 or SN1. Okay. So first we see the SN2 mechanism. Okay. So you know that SN2 mechanism is favorable by the primary alkyl halides. So which alkyl halide shows SN2 mechanism? Primary. So let us find out which alkyl halide is primary here. So in this case, this alkyl halide is a primary here. In the case, this is a secondary here. So this is again the secondary here. Okay. But in this case, this alkyl halide is the tertiary alkyl halides. So among the four alkyl halides, which alkyl halide shows SN2 reaction faster? So that's why there is a need to see. So this is a primary alkyl halide. So here primary carbon it is attached with the phenyl ring, no doubt. Here secondary alkyl halide it is attached with the 2-phenyl ring, and here we are. But in this case, what are the secondary alkyl halide? It is attached with 1-phenyl and 1-CH3. So from that four, you easily understand which alkyl halide shows faster reaction here. That is A. So we write the order A because A is the primary electrolyte, no doubt. Okay, so that's why it shows faster SN2 reaction. But what about the B and C? So among the B and C, let us see these two molecules. So from that, this carbon is the primary, so it is attached with one phenyl, it is attached with the another phenyl. But in this C, what is the C here? So it is the secondary carbon is attached with the one phenyl and another here one CH3. So what is the difference between these two? So here there is a two bulky phenyl group, but here only one phenyl group and one CH3. So comparison between this B and C molecule. So these B molecules having bulky group more compared to C molecule. So that's why C molecule shows faster SN2 reaction than the B. Okay, so that is the difference between B and C molecule. बघा B आणि C मध्ये डिफरन्स काय? B मॉलिक्यूल मध्ये या कार्बनला किती फिनाइल ग्रुप अटॅच आहेत दोन, पण C मॉलिक्यूल मध्ये कार्बनला किती फिनाइल ग्रुप अटॅच आहे ओन्ली वन, आणि दुसरा कोण आहे CH3. बघा CH3 आणि फिनाइल मध्ये कंपेअर केलं तर CH3 हा छोटा ग्रुप आहे कंपेअर टू फिनाइल, म्हणून C हा काय करेल फास्टर SN2 रिएक्शन दाखवेल कंपेअर टू B. And last one, it is always this is the tertiary, so that's why it is always shows less or slow SN2 reaction. Okay. So what about the SN1? So you know that in the case of SN1 and SN2, just reverse thing happen here. So D molecule is a tertiary electrolyte, so that's why it is reacts faster compared to B, compared to C, and compared to A. बघा आता SN1 आणि SN2 ची ऑर्डर काय एक्झॅक्टली रिव्हर्स असं घ्या. SN1 मध्ये D मॉलिक्यूल टर्शियरी इलेक्ट्रोलाइट्स आहे म्हणून तो फास्ट होणार. राहिला प्रश्न B आणि C. आता बघा B आणि C मध्ये बल्कीनेस कोणाचा जास्त आहे? B चा जास्त आहे, म्हणून तो काय करेल SN1 दाखवेल कंपेअर टू C, आणि लास्ट वन आला A. ओके, सो these are the some examples. So how to write or how to arrange the molecules according to the SN1 or according to the SN2 mechanism. Okay. Next we will some example here again. That is I take here primary alkyl halides. So that is the thing with the I take here this type of molecule. So next example. So this is a type of molecule. So you call it is a N-propyl chloride, no doubt. You know very well bond line formula here CH2 CH2 CH3, and I place here KOH or NaOH, but the condition here alcoholic. Okay, so at that time the reaction is always favor through SN2 mechanism, no doubt. Reaction is always favor through SN2 mechanism because this carbon is a primary. Because this carbon is a primary, and primary electrolytes always shows SN2 mechanism. But I take some nucleophile here, weak type of nucleophile. So at that time the reaction it goes through SN1. But before that we just see here. So this is a primary alkylides. So N-propyl chloride. So it is a reaction with alcoholic KOH or NaOH. So you will get the N-propyl alcohol. So that is you can say the propanol. Okay, so it is an N-propyl alcohol. So that is the only one product here. But in some cases, suppose if you take this type of molecule and again you take here KOH, so again that reaction is also favored by SN2 mechanism because you use here KOH, strong nucleophile, and that strong nucleophile is always attack on that primary carbon, and the Cl group is leave here, and you will get the allylic alcohol. So like that. So this is the allylic chloride, and you will get the allylic alcohol. So no doubt. So reaction condition decides. So reaction condition decides. The reaction is goes through SN1 or SN. So this is the allylic alcohol. So these are some examples. But if you remove, if you change here nucleophile, so this KOH is a strong nucleophile here. So it is a strong. But if you change strong nucleophile by the weak nucleophile, at that time the reaction condition is different. At that time the reaction condition is different. Okay. So let's see one example. I take the same molecule here. So this is the same molecule. There is a allylic chloride. So that allylic chloride, but I change nucleophile here. I does not take the strong nucleophile. I take the weak nucleophile, that is water. You can take the nucleophile as water. At that time, the reaction is goes through SN1 mechanism. So why this happen here? Because nucleophile is not strong. Nucleophile is not strong. So that's why there is a generation of carbocation, and that carbocation is stabilized by the pi bond. Okay. And after the generation of carbocation, what is the OH minus that they obtain from the water, that is attack on this carbocation, and you will get the alcohol, allylic alcohol, no doubt, but the reaction is goes through SN1 mechanism, because water is a weak nucleophile. Water is a weak nucleophile, and weak nucleophile असल्यामुळे reaction कशी गेली SN1 mechanism. Okay, so there are a lot of examples that are regarding the SN1 and SN2 reaction mechanism. Okay, so today we stop here. We will take some another example in the next lecture. Okay.